So what we're going to do is plot these things called polar coordinates. They're a little bit different than rectangular. Rectangular had this x and y. It's what you've really plotted for years. It looks like a little rectangle thing. And we have x, y. We're now going to do polar, which are circular coordinates. If you think of the Earth, it's circular, so it's kind of the thing that airplane pilots use and radar displays have. They locate, and you've probably seen these in movies. So polar coordinates are a little bit different. They're going to do r and theta. R is really the distance, and it kind of is r because we're going to kind of call this array. Array, if you recall, starts at one location, which we're going to call the pole, and it's going to go kind of like it did on the positive x-axis because we're going to measure angles up and down from that axis. This theta is my direction. And we always measure positive off the x, negative off the y. So that hasn't changed at all. So we're going to plot some points here. Let's plot A, and let's make it 3 and pi over 4. So 3 is the r, so I'm going to go out 3 circles on pi over 4. I'll label it A. Let's plot some negatives. B is a coordinate 2 and negative 5 pi over 6. So I'm just making these up so you can see how I might put some negatives into this. That's a 2. So negative 5 pi over 6 is you're going to measure down. And this is 6 pi over 6. So I'm a little shy. So this is the same as negative 5 pi over 6. And I want to go out 2 on that ray. So here would be my B. Okay, let's try another one with a negative. Let's go point C, and let's make it negative 3 and 5 pi over 3. So 5 pi over 3 is my angle, which is right here, but this negative says go back across. Out on the ray is positive, back across, and if you notice, these points right here are a reflection just of these right here. So there's kind of this 180 degrees, which is going to come pretty important here in just a minute, because we can have points that are the same but have different looking coordinates. And how would that happen? Well, if I gave you r and theta, and we plotted a point, I could, doesn't really matter where, I could get to that same point if I took and added 2 pi. 2 pi says I'm just going to go around the circle again, and so it would match me up to that same location. Another way I can get there is I'm going to plot this point because I think it'll be easier for you to see. I'm going to plot 3 and 3 pi over 2. So if I'm going to plot that point, 3 on this ray, I could get to that ray, or get to that point, if I used pi over 2. And instead of going out, I would want to go back. And so if you notice, these are off by this degree of 180. So I can get there as well if I have these 2 points are off by 180 or off by 360. So the negative made that different direction. So you get to kind of explore that a little bit on the homework assignment that you'll be doing for plotting points.